These questions are tricky, but using a productivity table gives you a chance. These questions are all about 8 men mow a lawn that's 20, and how long would it take for 50 men to mow a lawn that's 800 or something or other. Let's have a look at the lawn mowing man. One man takes 1 hour to mow 200 square meters. How long does one man take to mow 400 square meters? Well, we've got a picture of the man and we've got more to mow. So the first 200 square meters takes an hour, and the second 200 meters squared also takes an hour. So in total, it's 2 hours. You can see you've doubled the task and you've doubled the time. If you double the task, you double the time. Not a surprise. And I remember it with this: time times tasks. It'll make sense later when we look at a table. Time times tasks. We know the data. It takes 1 hour to do 200 square meters. So if it's 400 square meters, well, we've doubled the tasks and we're going to times this by 2. We get 2 hours. Similarly, if we halve the time, we've gone from 200 to 100, we've halved the task, I should say, then we half the time. It'll only take half an hour. The assumption is that the chap works at the same pace throughout. So doubling the task doubles the time. There's no great surprise there. What about if we bring more men on the job? One man takes 1 hour to mow 200 square meters. How long do 2 men take to mow 200 square meters? Well, there's our man and there's his friend, an identical man that works at exactly the same speed. The first man mows 100 square meters, that's half the area, in half the time, half an hour. The second man mows his 100 square meters in half an hour. They're both at it at the same time. So the 2 men take just half an hour to mow the same quantity. Now, it's not a surprise. You've doubled the manpower, so you've halved the time. If you double the doers, you halve the time. And I'm calling them doers because sometimes it's men, sometimes it's machines, sometimes it's staplers, sometimes it's robots. Essentially, they're all doers. So the time divides by the doers. If you double the doers, you half the time, and then you've got a little table here. So if the time is 1 hour for one doer, and you double the number of doers, you're going to half the time. And equally, if we quadruple the number of doers from 1 to 4, we divide the time by 4, and we get it in a quarter. 4 men, 4 mowing machines will only take a quarter of an hour. Now, when it comes to questions, they combine changes to the quantity of tasks and the number of doers. So this is the table that I would use if I had this question. There's the time, which is what we're going to work out. There's the tasks, which if they increase, we increase the time. And there's the doers, and if they increase, we reduce the time. Let's have a look at a question. 2 machines can label 1,000 letters in 3 hours. How long will 4 machines take to label 3,000 letters? It's one of those questions where you just go, can't do that. Well, let's have a think. Let's put in the information we know. We know it takes 3 hours to do 1,000 letters, and we've got 2 machines, 2 doers. And what we want to know is what happens when there's 3,000 letters, there's 4 doers, and we want to know what the time is. Now, we can move from here to here gradually. In fact, I pretty much insist we move gradually. We change one of these values at a time. The first one we're going to change, just because it's the first one we come to, are the tasks. Let's increase this to 3,000. We're going to keep the doers the same. So I should just point out that's a multiplication of 3. And we'll keep the doers the same. So all we've done is we've increased the tasks threefold. So the time increases threefold. It takes 9 hours for 2 doers to do 3,000 letters. But we haven't got 2 doers, have we? We've got 4. So the next thing we do is we bring 4 here, which is a multiplication of 2. We keep the tasks the same. And now, having doubled the number of doers, we're going to half the time. And we're going to divide it by 2, 4.5. So it takes 4.5 hours for 4 doers to do 3,000 letters. And that's your answer. So the maths isn't difficult at this stage. It's just knowing what to do. It's just basically not freaking out. So let's have a look at an actual question. It takes 3 people 6 days to mow a grass. It's a very big grass verge, that is. How many days would it take 9 people to mow a grass verge that's twice as long? Okay, so time times tasks divided by doers. Let's get our columns together. Time times tasks divided by doers. And it's 6 days. We have 1 grass verge to mow, and we have 3 doers, 3 people. What we want to know is when the task is 2, twice as big, and we've got 9 people, what is the time it takes? And again, we move down, changing one of these columns at a time, and I'm going to change tasks first. I'm going to say that there's 2. We've doubled the grass verge. That's times 2. We've kept the number of doers at 3, and so the time has doubled because we've doubled the tasks from 1 to 2. So that's going to be 12. And the next stage, we've got the tasks right. We need the doers to go up from 3 to 9, and that's a trebling of the doers. We keep the tasks the same. If we treble the doers, we divide by 3. So we divide by 3, and it's 4 hours. 4 days, I should say. 4 days for 9 doers to mow a grass verge that's twice as long. And finally, this is the hard one. 3 marks for this. Again, they're coming in later in the exam. Time times tasks divided by doers. Times tasks divided by doers. 2 T's here. Times tasks and 2 D's divided by doers. That's why I hope it's memorable. So the information we are given, it takes 3 hours for 5 tons to be unloaded by 4 doers. And we want 10 tons, and we want 6 doers, and we want to know what the time is. Well, the easy one is 5 to 10, isn't it? So let's just make this 10, which is a multiplication of 2. We'll keep the doers at 4, and the time now doubles because we've doubled the task. So it's 6. It takes 6 hours for 10 tons to be downloaded by 4. Now, 4 to 6 is awkward. It's not an easy multiple. So the standard way of doing this, and this is what I would suggest doing, is you divide this by 4 to get 1. We take it through 1. We're going to keep the tasks the same, obviously. Now we're dividing, we are reducing the doers by 4. Therefore, the time taken is going to increase because there's only 1 man. There was 4. There's only 1 man. The time is now going to go up 4-fold to 24. It takes 24 hours for 10 tons to be downloaded or loaded by 1 person. But now we've got it easy to get from 1 to 6. We just multiply by 6. Obviously we keep the task the same, and now we are increasing the number by 6, so we divide the time, and it's 4. 4 hours for 10 tons to be loaded or unloaded by 6 doers. 3 marks. That's a pretty tricky thing. This is a tricky line. We'll see how it goes. Anyway, I think we've taken a hard question and made it, it's still tricky. But if you've enjoyed this, or even if you haven't, why not subscribe? There's plenty more. Thank you.